Welcome to the chromatography experiment. This is experiment 7 in your lab manual, and be sure to read the background material in the lab manual before proceeding with the video. In this experiment, we're going to have a solution. Water is going to be the solvent, and our solute are going to be food dyes. The ultimate result, we're going to take a mixture of food dyes and we're going to separate them out using chromatography. The solution of water and the dyes will move across the face of the chromatography paper. Some of the materials will move more slowly or quicker than others, and the difference between those and the solvent will allow us to calculate what is known as retention factor. Different retention factors for different components indicates that they are in fact different components. Of course, because these are food dyes, another thing we can use to confirm our results is the appearance of color itself. And with that, let's move into the experiment. Following along in the lab manual, you'll note that we need to now mark up the piece of chromatography paper. We need to place some markings so that we can use those as guides for placing our solution samples on to the chromatography paper. Noting the sample provided to the right, the little cartoon there, A through F, the bottom line there, the bottom horizontal line represents what is known as the baseline. And in this case, A, B, and C are just generic placeholders for the solutions of the food color dyes that you're going to place onto the filter paper. And ultimately, everything's going to move up the paper, and the thing that is going to move farthest is the solvent front, and that is shown. Now that you've got your baseline marked with some tick marks that will represent the location that you will place each of your food color dye samples, let's now label that baseline as to which food color will go onto which mark. Also, the right two will be your two unknowns designated as U1 and U2. Each of the food dyes shown, as well as the two unknowns. First thing we need to do is to get a sample of each of those dyes, and then the second thing we will do is, once we have those samples, we will spot a very small amount of each one of them onto the piece of chromatography paper. Now it's time to spot the chromatography paper with each of the respective samples. Oddly enough, one of the best ways to do that is with a toothpick. Sometimes low-tech is the best way to go. Of course, a different toothpick is used for each sample to avoid cross-contamination. Next up, we prepare the development chamber, which in this case is just a large beaker. Into the beaker we will place some of our solvent, water. We must take care that the water level does not reach or go above the baseline. Now let's develop the piece of chromatography paper. And by develop, we mean we will let the solvent run up the piece of chromatography paper and each of the food dyes with it. Some have a high affinity for the water and will travel almost at the same rate that the waterfront moves. Others have less an affinity for the water and a slightly greater affinity for the piece of paper, and so it will lag behind a bit. And it's this lag that helps us differentiate the materials that are in the solution. Once it's been developed, it needs to be dried, and then we can perform our analysis. It can be air dried or most often placed in an oven. You can faintly see the outline of the solvent front. It looks a bit like a stain. It's not exactly horizontal with the paper, so we will draw it as best we can. This then defines our solvent front, one of the two key measurements we need. The second measurement we need is how far each of the dots, each of the samples moves from the baseline. To do that, we'll mark the maximum distance that each dot traveled. And then we're going to come back and measure the distance from the baseline to that dot. And that is what is meant by processing the data. So for red dye number 3, the 0 point on the ruler is placed against the baseline, and you now should read and record the value of the dot displacement from the baseline as well as the distance to the solvent front, and those will be recorded on your report form. Now red 40. Record those two values. Yellow number 5. Yellow 6. Blue dye number 1. Blue dye number 2. Green 3, and now for unknown 1, which is a mixture of two different materials. And unknown 2, which also has 2. Now all that remains that you know the distance each dot traveled and the distance the solvent traveled is to perform calculations of RF for each dot. Shown here is an illustration of how to do that. And there you have it. Record all of your data. Calculate the RF values for each of your dots, and then identify your unknown components. That's it. Thanks for watching.